Okay, so we are going to wrap up Unit 3 with the last 3 lessons here. We're going to begin with Unit 3, Lesson 4, something called Relations and Functions. So we're going to get used to what we call function notation, and we're going to also identify relations between what we call the domain and the range. So the domain is what we call the input. It's usually an X. Usually X, and the range is the output, and it's usually Y. But in this situation, we're going to change, instead of having Y equals 15X, we're going to change Y into something we call the function of X. So this is down in high school, it's going to be a lot better when you understand the function of X. Also, you get to freely choose your domain, your inputs, so we call that the independent variable. For example, I could put in 0 for X, I could choose 1, 2, 3, but what comes out is 0 times 15 would be 0, 1 times 15 would be 15. So that is, the output is dependent on what you choose. So we're going to evaluate functions. We're going to build a function table the same way we did the graphing with tables. We're going to make sure that our input values that we pick are going to be equally distant from each other. So we went along the number line and we picked, let's say I went by threes, so I'd be -9, -6, -3, 0, 3, 6, 9, etc. So I want to make sure my inputs I choose are equidistant. And then I want to be able to find or calculate my output values, my range. We're going to graph these linear functions, and we'll plot them on an XY axis. And we're going to be calling it X, and instead of Y, we're going to be calling it the function of X. So it's just something to get used to, something new, and we'll be on a coordinate plane. So if you are following along in your book at all, we would be on page 288. That's where you'd find parts of this lesson in your textbook. So here you can see a very simple, this would traditionally be written Y equals X plus 5. You have, again, free choice to choose your domains. Here, the coefficient is 1. So we don't have a fraction as a coefficient, so we can go ahead and just choose numbers that are going up by 1, equidistant, and our corresponding outputs, because it's 1 times X, are only going to change by 1 also. So -2 plus 5 would be 3, -1. So you're substituting in. This value gets substituted in for X. And then you get your outputs, and your outputs are going up by 1. And if our coefficient had been 2, these would go up by 2. If it had been 3, they'd go up by 3. Same thing with negative. If that had been -2 in front of X, these would change by -2. So we're going to build these function tables, okay? And we've already talked about the inputs, the domain is your independent variable. And then whatever your function is comes out, the range. Let's take a look at that. You won't find this equation or table in your book, so don't look for that. Don't look for the table or the graph. And the graph is in your book, but not the table. So this table, if you don't have the notes, you could do this table, make your own 4-column table. When you make 4 columns, there's only 3 interior lines to make 4 columns, because you have a starting line at 0, and then 1, 2, 3, 4. So we're going to pick our values. Now let's see. X is here, and this is our input, is our independent choice. And it looks like we're going to be multiplying times -2/3. So I have to think to myself, what values would I want to pick independently? Because when I multiply it, this number's in the numerator. So I'm going to have -2/3 multiplying times a number. And then I have +5 over here adding to it. And I have f at x, or y. This used to be called y. So I have net positive 5 minus 2/3. So I'm going to choose a number. Now, it wouldn't be smart to choose the number 1 or 2 here. Let's imagine I picked 2. Uh-oh. Then I'd get positive 5 minus 4/3. That's going to be, that's no. Bad. Bad choice. I don't want to do that. So I'm going to say, no, don't do that. A better choice would be, I know it's being divided by 3, so I need to choose multiples of 3. So let's choose multiples of 3. Okay? Because I also, you know what? I need to get numbers that are left and right, so I can get a nice line that goes diagonally. If I look at this slope here, the slope of this line is equal to negative 2/3. We learned how to graph this, and we have a y-intercept of 0, 5. So before I start to graph it, I know that the slope is negative, so it's going to be something like this, and it's going to go through 0, 5. So my line's going to be over here. So I want to choose some values left of the origin, 0 of course, and then 3 and 6, and that'll get most of my points on the graph. So I'm going to try negative 3, 0, 3, and 6. And now I substitute into the equation. I can rewrite this equation if it's going to be a little bit easier. Instead of this, I could write it with the variable term first, which I like to do. Let's write it with the variable term first. And then, remember, this is positive 5, so plus 5. That's the commutative property of addition. And now we're going to evaluate. Now, the neat thing about using this f at x is we can always know what value we picked. If you used y, you wouldn't know that. So we're going to choose the function when x is negative 3, when f is 0, positive 3, and 6. So here we have negative 2/3 times negative 3 plus 5. Negative 2/3 times 0 plus 5. That one's easy because that's 0 plus 5, or 5. So I always want to probably find my location at 0, 5. We know that that's the y-intercept. That's the most important point, 0, 5. 0, positive 5. Let's go ahead and do the math here on this one. Negative 2 times negative 3 is positive 6 over 3. So 2 negatives made a positive 6 over 3 plus 5. 6 over 3 is 2 plus 5, so I get 7. And I'm going to graph the point negative 3, 7. So I go left of the origin. Remember, the origin's at 0, 0. The first number, negative 3, tells me to go left 3 and then up 7. I'm going to go ahead and mark that. I'll mark this one. And I'm almost done. Negative 2/3 times 3 plus 5. Okay. Remember, these dots, this next dot should be here because it's got to line up in a straight line, hopefully. I'm already anticipating it going this way. I know the slope is negative 2/3. That means down 2, right 3. Down 2, right 3. So it's got to follow that pattern with our other method of graphing in slope-intercept form. All right, negative 2 times positive 3 is negative 6 divided by 3 plus 5. That's going to be negative 2 plus 5. Negative 2 plus 5, what is that? It's 3. So I'm going to graph 3, 3. Okay. And now I'm going to do f at 6. That's going to be negative 2/3 times 6 plus 5. Okay. Well, we're rolling right along. Negative 2 times 6 is negative 12 over 3 plus 5. So that's negative 4 plus 5 is 1. Negative 4 plus 5 equals 1. And I'm going to graph 6, 1. So here I go to 6, 1. And I'm going to line it up. I'm going to label this 6, comma 1. I'm going to connect the dots. And I am finished graphing using a function table. Okay. My domain, if I was to list my domain, I use these special little brackets right here, or braces I should say. I could list these negative 3, 0, 3, and 6, or I could say that my, if I was to state my range, that outputs were 7, 5, 3, and 1. That's the ones I used. Okay, so we're going to break these lessons up. The next lesson that you're going to see is going to be lesson 5. So keep your notes close, and we're going to continue with lesson 5 next. And keep all these notes nice and orderly in your binders. This is going to be the last set, so this will go in the front, or if you're going to go from earliest to latest, that's the way I do it. Put the lesson 1 at the bottom and then go up.